Welcome to the Sentinel Hub webinar. Today we will focus on how satellite data can empower environmental NGO work, and the topic will be presented by my colleague Andrzej Zlinski, whose presentation will be then followed with a Q&A session at the end.
Hello everybody, welcome to this webinar. First of all, let me introduce myself in a few words. My connection to NGOs is something actually really important for me. I started my professional life as a scientist, as a wetland biologist, also working in remote sensing, working on Lake Balaton, one of the largest lakes in Europe, which is located in Western Hungary. I was also involved in decision support work for the Hungarian National Water Directorate. And then with a couple of friends and colleagues, we started an NGO called Szabadon Balaton, which means Free Balaton. This is actually about scientific outreach and spreading scientific messages, communication together with artists. So we work not really in advocacy, but more in the science policy or the science journalism interface, but we work closely together with artists. And since 2023, I am the community evangelist for Synergize, and my most important task is to communicate, to do scientific outreach about Copernicus data space ecosystem. And I'm going to introduce Copernicus data space ecosystem in a couple of minutes. So during this webinar, I will first introduce Earth observation very briefly, and then I will walk you through some case studies which are actually possible to follow on your own laptop later on if you work through the recording once more using the sharing links. And from simpler to more complicated, from long-term to more short-term cases, we will take a look at what can be done for environmental NGO work. Now, I'm trying to be very generic because I know that environmental NGOs are about as diverse as we people are. What connects us is a concern about the climate, the water, the biodiversity crisis, and the understanding that we have to reach out to society. Some of us are working on an international domain and specifically focusing on climate or biodiversity or water or whatever. Many countries also have national or regional scale environmental NGOs, but even like micro NGO groups, neighborhood activists, or groups of active friends are non-governmental organizations in the environmental domain. And even these small groups can benefit from the power of satellite imagery. So, introducing the term Earth observation. Earth observation is the process where we collect information from the surface of the Earth, from remote targets, using satellite imagery. Satellite imagery is turning into a public utility, just like water or internet in a way. It allows us to observe processes happening on the surface of the Earth at scales where we wouldn't be able to understand them with our own eyes. And many sensors collect data in a systematic way. So the satellites are actually orbiting the Earth every day, and they are collecting every single image as they pass over the surface of the Earth. So this means that you can count on the data being there, and you can count on the data being publicly available, at least from the Sentinel and the Landsat program. And now to go into a bit more detail, and I won't be very specific about this, there's a couple of terms you have to become familiar with, and these are spatial resolution, temporal resolution, and spectral resolution. If you think about your camera or your mobile phone camera, you know how many megapixels it has. So this is the amount of individual pixel elements that are present in a single image. And depending on how close or how far away you are from the target that you are taking a photograph of, these individual pixels will resolve larger or smaller areas of the environment. If you're photographing a document, just instead of scanning it, then one pixel is probably going to be a couple of tenths of a millimeter. If you are using a telephoto lens and you are photographing for a large difference, then one pixel is going to be several meters. This is spatial resolution. The same thing applies to satellites. So some satellites have spatial resolutions of a couple of tens of meters typically, others hundreds of meters or even kilometers. This is spatial resolution. High spatial resolution is easier to interpret with our own eyes, or it's easier to share with the public. Now, temporal resolution or cadence is something different. This is how often the satellite takes a picture of the same area. It's also called revisit time. So some satellites, they pass the same place on the Earth only once in a couple of weeks. Other satellite systems take a picture of the Earth, of every point on the Earth's surface every day or every couple of hours. This is temporal resolution, the frequency, the number of images that are obtained in a given time period. And the complicated one is spectral resolution. you know that light is part of the electromagnetic spectrum. We have all seen rainbows. Rainbows are because of the different wavelengths of light. But electromagnetic radiation does not only stop at the interval of light visible to the human eye. We know we have ultraviolet light, we have infrared light, we also have radio waves. So depending on the wavelengths, depending on the energy, different parts of the electromagnetic spectrum can be recorded. Our eyes, they work in the red, green, and the blue channel. Also, most terrestrial cameras work the same way. But satellites can actually be sensitive to different parts of this electromagnetic spectrum. And let me show you an example here. This is a Sentinel-2 image with a small spectral processing script applied to the right-hand side. So what you see on the left is a true color image. It's here you have the sea in the north. You have a terrestrial area, and what you see is wildfire smoke. And you can't see much through the smoke. But if you swap the red channel for one of the infrared channels, then you will be able to highlight the thermal energy of the wildfire. The fire is not actually as yellow and red as you see it here. We are substituting yellow and red for the energy of the fire, and this makes it visible through clouds. So this is how spectral resolution helps you find information that's not visible for the naked eye. And Sentinel-2 and Landsat are free sources of RGB or true color images, which is why it's relatively easy to use them for scientific outreach or for communicating with the public. I just want to show you briefly, if you're interested in Earth observation in more detail, there's a free course on EO College, which really introduces you to all the detail, all the complicated parts of Earth observation. So we all interact a lot with images. In the era of smartphones and social media, it's very easy to take an image and to share it with hundreds or thousands of people in a second. We look at a lot of images. So images actually compete for our attention in this world because we receive so many of them. Moving images or time lapses or surprising images are a lot more powerful. And the essence of satellite imagery is that it opens up spatial and temporal and spectral scales that we would otherwise not be able to observe. Take a look at this picture. I guess some of you have seen it already in the news. This is the recent drought in the Amazon basin. This is the Rio Negro. And I think it's easy to guess that large areas on this image are typically underwater. They are uncovered because of the extremely low water level. And I want to point your attention to the scale bar here on the left. This is 1 kilometer. So you could spend all day walking through the scenery, and it would be still quite difficult to put together the big picture of what is actually happening. But through a satellite image, you can take a glimpse, you can share it with a lot of people, and everybody understands that this is a dramatic image. Something is wrong in this image. And this can be done at scales that we would otherwise not perceive. And satellite imagery also serves as evidence. And we have seen many very sad cases of this in the news related to recent conflicts. The open source intelligence community is built on using satellite images to infer actually what has happened in a specific place. And this can also be done for environmental cases. For environmental issues, it's also possible to follow up using satellite data to see what actually happened. And if the image is sourced from an official data infrastructure, an official open portal, and anybody can look up that image and see with their own eyes that this is the official one, then it's a lot more powerful. So how do you find satellite imagery? Well, the easiest source of satellite imagery is the Copernicus data space ecosystem. Copernicus data space ecosystem is the default gateway to Earth observation data based on the European Copernicus program. So this website offers you a lot of information on satellite imagery. There are many different ways to access data using your code. It also connects to the industry ecosystem built on Earth observation. But the important part is the Copernicus browser for you. So the Copernicus browser is a very simple, very intuitive interface, which has a calendar where you select the date of the image you're interested in. And it has a map view, which you can scroll and browse around. And it has different combinations of bands, different spectral properties that you can highlight. So this is how the Copernicus browser works. And now if we want to come back to just a very simple use case, if you're an environmental NGO and you want to highlight the speed of climate change, for example, you can Google fastest shrinking glacier. It's going to be a a relatively easy thing to search. And you can find information on glaciers. And one of the information pieces you find is that the northern Patagonian ice field is the most threatened or the fastest shrinking area of glaciers. So you can actually browse straight to the northern Patagonian ice field in the Copernicus browser. And this will give you, if you change the base map to the Sentinel image mosaic, it will give you a very simple image of the ice field. I want to point your attention to the cloud slider here. So this is going to define the threshold of cloudiness that you still find acceptable. The lower this threshold is, the more images you are discarding because of clouds, and the ones that are highlighted are the ones that are not very cloudy. So this is November the 1st in 2023. You can see that it is summer on the southern hemisphere, and it's relatively easy to find the points of interest or the glaciers. So we can do a small case study with this particular glacier, the Glacier San Quentin, which runs into this basin. This is the current state of the glacier. So how far back can we go in time if we want to look at change? Well, let's see on the calendar. We can go back to 2016. We have to make one small adjustment. Level 2 means pre-processed corrected imagery. For 2016, for the first year of the Sentinel-2 program, we only have more or less raw imagery available. But if we go back to October 2016, we can have an image that shows us the change. So look at the glacier. This is what it looked like in 2016, 7 years ago. And we can add this to a comparison to do a small on-screen comparison of the situation then and now. If I just go add to, and I click add to compare, then you see this little number coming up here. And now we go back to the latest image, and we add that one to the compare as well. And now if we click comparison, a new window opens up. We have the 2023 image on top, we have the 2016 image in the bottom. And so if we move this slider, we can actually compare the situation between then and now. And using the measurement tool, we can actually say that the lobe of the glacier extended some 4 kilometers longer in 2016 than it did today. So this is just a very simple measurement, a very simple collection of information that you can do. But how can you actually share this data with people? Well, if we go back to the image view, here on the right-hand side, you have image download. So this allows you just to download a JPEG or a TIFF or a PNG of this specific place. But you can also use analytical download, which gives you all the spectral blends. Or you can even go to high-res print, which gives you actual print quality images of the place you want to see. But if you want to share the image on social media, here's the share button. And if you click on this and click generate, then it's going to give you a short link. And this link can be very easily copied and pasted into a text or a tweet or any other social media entry. And it will allow your readers to directly interact with this platform and to directly see the results on this platform here. So we've seen a comparison between 2016 and 2023. What if we want to go back a little bit longer in time? Well, I have to point you to a different portal. This is the Sentinel Hub EO browser. The Copernicus data space ecosystem is completely free and open. The Sentinel Hub EO browser is commercial, but it also has a free tier, so it's also accessible for viewing and basic data export with the free subscription, but you have to subscribe. And so the Sentinel Hub EO browser allows you a lot more different sources of data. And here, the historic ones, the interesting ones for you, are probably starting with Landsat and Landsat 1.5 and Landsat 4.5. The Landsat program started in the 1970s. So moving back to the very same place, we can look at this glacier and we can identify how it looked like in 1976. You see that this whole basin was filled out with ice back then. Again, let me show you the scale of this process. The terminal lobe of the glacier is more than 8 kilometers across. So using these simple tools, it's possible to educate your audience about the scale and the speed of processing happening on the Earth. Let me give you another example. This is a place near my favorite lake, Lake Balaton in Hungary, Ajka. what you see here is an aluminium factory, and these are the tailings ponds. Aluminium production often involves the creation of so-called red mud or red sludge, which is a byproduct. It's a fluid or a muddy substance very rich in iron and very alkaline, so actually quite toxic. And this is stored in tailings ponds. And in this particular situation, we are now in September 2010. If we just select the date after this, the 9th of October, we will see that something is completely wrong, right? The dam is breached, the red sludge has leaked out, and now we can follow its path through this river valley, how it actually affected quite an area of this small village, and how the pollution continues for kilometers and kilometers along the river valley all the way downstream. So again, this is a disaster at a scale which is very difficult to comprehend as humans. You can stand at one point, but it's very difficult to have a feeling for several tens of kilometers of polluted river. And with images like these, and with the tools available in the Copernicus browser or the Sentinel Hub.io browser, you can actually show your audience or your followers how these things happen. And let me move on to a different use case. This is an ecological process. It's not actually connected to pollution. It's a so-called algae bloom. So algae are tiny unicellular organisms. They do photosynthesis similar to plants, so they live off the energy of the sun, and they are green. And here on Lake Balaton in 2019, we had an algae bloom where the algae had a period of extreme growth, which really changed the water quality conditions. So one way we can create an actual moving picture or an animated GIF of this is to use the time-lapse animation tool here in the EO browser. If we just click on it, and we select this area, then it offers us a similar calendar view and the opportunity to select images based on tile coverage and cloud coverage. Tile coverage means how much of the image area is actually covered by the satellite image. So if I apply a stronger threshold, then you will see that the pictures where only part of the lake was covered, they disappear. And I can apply a threshold to cloud coverage. And now I can look at my time frame, go from the 1st of August to the 20th of September. We select one image per day for the moment, and we hit search. And now the system is querying all the images within this time frame that cover this specific area and creating this list of them. It's usually a good idea to scroll through and check them one by one to make sure they're not very cloudy. And now if I hit play, then this GIF is actually playing, and you can see the date of the image in the top right corner. And now the lake is turning green. And now it's going back to normal again. So this is the spatial and temporal extent of the water quality problem that we observed on Lake Balaton. And again, it's possible to download this GIF, and it's even possible to obtain a sharing link where you can share it directly in social media. Now, some processes are not so easy to see with our own eyes. Sometimes it's better to try and find some more complex visualizations. And here, the Sentinel Hub custom script repository is a really, really nice resource. This has different algorithms, different spectral calculations that you do with the pixels of the images that will highlight various processes. So we have scripts for disaster management, we have scripts for vegetation, deforestation, and we also have scripts related to water quality, water bodies. And these custom scripts, they work like this. You define some parameters, you take the individual images, the data sources, you perform some calculation, and then you apply a palette, a coloring system to the output. So what we did here with this water quality viewer was we applied a color scheme from blue to red for chlorophyll, so the amount of algae in the water, and we applied a different color scheme depending on the sediment content, which is changing the transparency of the water. And now if you look at this same image of Lake Balaton using this palette, using this highlighting algorithm, then it's a lot easier to actually identify the extent of the problem, and it's a lot more compelling to to show your audience or your followers how the process actually happened. Again, we can create the same time lapse, and then we can see how the process happens. Moving back to here we are. So this is the time lapse on screen. You see sometimes the lake has a lot of sediment, which is mixing up, and then the algae content grows, and then it recedes again as the year ends. So this is the type of visualization. This is the type of image product that you can actually produce using satellite imagery in the EO browser. And again, these images can be really compelling when you want to support a message. What we wanted to say in this case is that we have a water quality problem that is unprecedented since 20 years. Now, we managed to find a Landsat image from 1995, which showed quite a similar water quality pattern than what we took to what we had in 2019. And so it's really easy to put these side by side in a news item or a social media item to share with people. Then, I mean, these spectral processing applications can not only be applied in an interactive way. There are also websites where this calculation has been prepared for you. Global Forest Watch is one of my favorites. It's an openly available data product browser, which is based on Sentinel and Landsat data. It actually allows you to take a look at the extent of deforestation. So again, in the interactive map view, this is globalforestwatch.org, and then you just click on the interactive map. With this slider, you can select the time interval where you're interested in deforestation happening. And this specific study area is called the Bohemian Switzerland National Park, and I know there was a wildfire there in 2022. And then using this data set, we can actually visualize the effect and the extent of the wildfire. It's even possible to derive spatial statistics. So Global Forest Watch is a really popular tool for environmental NGOs. Now, I want to come back to the issue of temporal resolution. Sometimes the 5-day or 10-day revisit time of public Earth observation satellites is not enough. If you actually want to identify a process in time, you might need a more dense time series. Let me show you this example. We have this this red oval-shaped thing, and inside this frame, we have wetland vegetation, again, on the shore of Lake Balaton. And now you see that the vegetation is gone. So this is the environmental issue. This is the case that we want to look at with a bit more scrutiny. An area of about 3 hectares of wetland has been lost sometime between 2017 and 2023. So the time lapse I created here, it spans quite a long time, actually approximately the amount of time where we have Sentinel-2 data available, because we first want to chronolocate this event. We want to identify when it happened. Chronolocation, this term again comes from the open source intelligence community. It's just the process of identifying when something happened. And if you look at this GIF, the other thing besides the wetland disappearing is you see that this is a major construction project here. Trees are being felled, buildings are rising, the roads are being paved. So this is the process that happens in parallel with wetland loss. And now, once we have used this long-term time series to identify the approximate period where this change happened, we can actually narrow it down and take a series of images from the summer of 2017 to the summer of 2018 to, again, identify the exact time frame. You see that the wetland is still here. As we move towards the end of the year, it's still here. And then at some point, it's going to disappear and we will be able to identify the exact timing. So now we have December, January. Bit of a dark image. See, now we have some change. And now it's gradually being lost. And now we don't see it anymore. Right? So this is the amount of information that we can collect using open satellite imagery, using Sentinel satellite imagery. We can narrow down the period of interest between the 3rd and the 28th of April. So where do we go now? If we want to use high-resolution commercial data, we have to subscribe for the EO browser. And this offers various subscription plans depending on the amount of data and the amount of processing that you actually want to use. And then once you have a subscription, in your Sentinel Hub dashboard, you can look at various commercial imagery packages that can be purchased. I can't show the prices here completely publicly, but I can tell you that once you are registered, you will be able to view the prices yourself. And the cheapest package, which is the Planet SkySat Archive plan, is a little bit below 150 euros. So this is the amount of money you have to invest if you need commercial imagery for a specific case. And so once you have identified the start and the end time of this process, you can actually search for commercial data. First of all, you have to create an area of interest. This is going to be our area of interest. Just extending it a bit further. And then you create a query. Remember, the time frame we wanted was essentially April 2018. So it starts with the 1st of April 2018 and ends with the 30th of April 2018. We are looking for PlanetScope data because this is the one with the highest revisit time. We want to do chronolocation. And then if we hit search, I have to log in again. If we hit search, we get a list of images, and we can actually take a look at them in the form of thumbnails. And we can decide whether we want to add them to our order. And then if we hit prepare order, and then we confirm the order using the Planet API key that you get when you register for your Planet data plan, then you can actually carry out the order process, and in a couple of minutes or maybe half an hour, the data is delivered to you. In this case, of course, I have already created this order, so it's here. This order is a sequence of images, and I can just pull up the data to show it to you. So this is the resolution of data. This is the additional data quality beyond what you get using the public data set. And it's actually possible to create a time lapse in exactly the same way as you would do using public data. So I go back to April 2018. And you can see that the image dates are here, similarly to what we had with the Sentinel data, with the public data. And then I can just add the data to my time lapse, and I can see what's going on. So now I have an image with a lot more temporal detail, with a lot more information on when actually something happened. And now maybe some of you already see an indication of why the wetland was lost, how this process actually took place. Let me stop the time lapse at this specific image. It's going to show you an indication of something important happening. What we see here is a sediment plume. So this is not actually just water, but this is mud. This is the wake of a ship. So apparently this vegetation area was lost not due to natural causes, but to some sort of dredging, some sort of activity in the lake floor, in the lake shore, possibly during this construction. I can't take it further than this. I mean, the consequences, you can draw them for yourself, but this is one way that satellite imagery can support collecting evidence for environmental cases. Again, once more, the time lapse. This image is going to be our key C. This is where the sediment is disturbed, and that's where this wetland area disappears. So just to wrap up, I want to point you to a couple of opportunities for accessing commercial data. The ESA Network of Resources has a funding opportunity that's also there for environmental NGOs. It provides sponsorship at the range of a couple of hundreds to a couple of thousands of euros in kind, not in money, but in data. And this can also include EO browser subscriptions. And this can also include commercial data in EO browser. So it starts at nordiscover.org. And Planet also has a nonprofit program. It offers training and also imagery to NGOs that are applying for this. There are two different bundles in this offer, and both of them are actually 95% discounted. So the data is not free, but it's a lot cheaper than what you could actually get on the data market. And these bundles are available for any organization that can prove, according to US law, that it is a nonprofit. So these are the two initial starting points if you want to work with commercial Earth observation data. So just to wrap up, satellite imagery is a really widely accessible data source. There's lots of processes that you can illustrate with satellite data. And the most important application is broadening the scale of our investigation. It allows people to see processes that they would not see with their own eyes because as human beings standing on the surface of the Earth, our views in space and time are limited. Global processes such as climate change can be highlighted. Local cases can actually be followed up at the level of evidence, and you can have really long-term information from Landsat. So I really want to encourage you to start exploring the data, to look at these tools, to even apply for funding. And meanwhile, thank you for your attention, and I remain here for your questions.
Thank you, András. So now we can proceed with your questions. The first question, András, for you would be, what happens if we have cloud cover? Is there anything we can do to collect data?
Yes, it's going to be a bit more complicated because, I mean, for the naked eye, clouds are not transparent, but many cases can actually be followed up using Sentinel-1 data. So Sentinel-1 is radar data. It gives you a bit of a different view on the Earth's surface. It's highly sensitive to topography, and it really shows forests or vegetation. But these data sets can be used to fill in gaps between optical data. So radar data is also something that you can explore, and it will also provide you some information in the meantime when you have cloud cover.
Someone wants to know, what is the accuracy of water quality estimation?
Well, that's a difficult one because with water quality, it's really complicated to create a robust global calibration. So what you need is sample data from your own location, from your own lake or river. And if you have these samples, then it's now possible to actually output the data statistics from the code, from the custom script, and then you can perform some sort of regression, like linear regression, that gives you a calibration for your own water quality products.
Do you know of a specific case where satellite imagery was used as evidence in an environmental lawsuit, maybe?
Well, the short answer is no, but the long answer is that this is actively happening for agriculture monitoring. So now satellite data is established as legal evidence with financial consequences in the cases of controlling EU agriculture monitoring subsidies. So in cases where the question is, did the farmer mow the area in time, or did they have a water protection buffer strip around their plot? This can be very easily followed up with satellite data, and this is actively being used to decide on subsidies all across Europe.
We got a question from David. He's usually working quite a bit on integrating geospatial analysis to reduce deforestation and forest degradation in indigenous territories in forest countries. So he's wondering how it can be used by indigenous people in monitoring their territorial autonomy.
Well, Global Forest Watch is a public data set, and now its use in following illegal deforestation is really well established. So Global Forest Watch is running since many years now, and its findings are often quite undisputed. So if you can prove using Global Forest Watch that you have tree cover loss in an area that's governed, for example, by an indigenous territory, and they say that this is not authorized, then it's impossible to say, well, nothing actually happened. And inside Global Forest Watch, there's also a high-resolution image product from the tropics. Hold on, let's see if I can just quickly navigate there. With the support, I think, of the government of Norway, high-resolution planet data is made available for the whole tropical forest area. And this is live updated, and so it's really possible to check what happened in these places at a daily basis even. So for your application, I would really recommend that you look a bit deeper into Global Forest Watch, because I think there's actual specific use cases for what you want to do.
Then one question came during your presentation when you were presenting the comparison of the glaciers. So the question was, are all those layers indicating the indexing available around the world? The participant was checking last month and only images were available in South Africa. And he's asking, is this accessible using specific tools or the normal way we access images using a location?
Well, the data products such as false color visualizations or NDVI are available everywhere. And also anything that you output from a custom script should be available all across the globe. Some satellites have limitations to their coverage, especially actually Sentinel-1. But if you can't access data for a specific place that's available everywhere else, then that could actually be a bug and you should report it in the forum. But don't forget to check the calendar. Maybe it's just that for that specific date, which you have set in the calendar, there's no data. And if you lengthen your time of inquiry, you can also use the time span tool, actually, where you select a start time and an end time, and it's going to create a mosaic of the images for you. If there's really no image for let's say, a month or so, and it's not because of clouds, then that could actually be a glitch in the system.
Begonia is interesting to know what is the relationship between EO browser and Copernicus browser. Can you tell us more about this?
Yes, most of the code is actually the same. The data sets are a bit different because EO browser is an initiative of Synergize of Sentinel Hub, where we try to collect all the free satellite data sources and also a lot of additional land cover data sources, elevation models, and commercial satellites around the world. And Copernicus browser is specifically governed by the Copernicus data space ecosystem. So this is a public data infrastructure sharing data collected from the Sentinel satellites. So for example, it doesn't contain Landsat. I hope that it will contain Landsat sooner or later, but at the moment it's only tuned for Sentinel satellites and for Copernicus data. But the technology is very close. Actually, the process is that Synergize is part of the consortium doing the programming for the Copernicus data space ecosystem. And one of the things that we were actually requested to do was to provide a data browser very similar to the EO browser in the framework of the data space ecosystem. So the data space ecosystem and the Copernicus browser is completely free. There's no subscription plan. EO browser is free or commercial depending on the level of data access that you want. And EO browser has more data sources, and Copernicus browser is the official one.
Tarek was asking if there are any data sets for historic or recent satellite imagery that are not commercial and at the same time higher resolution than the one which was shown, ones that enable recognizing human-made structures and finer details similar to Google Earth quality or higher.
Well, there's one thing I can show you in the data collections. It's not exactly there yet, but it's coming up. In Copernicus data space ecosystem, high resolution mosaic data of Europe is becoming available. So we are expecting VHR commercial data, all the data sets that have been paid for by the European Commission to be accessible for European projects are going to be available in the data space ecosystem. These are probably mosaic data, so combinations of data from different times and space to avoid clouds, and they are significantly higher resolution than Sentinel. But what you're actually looking at or looking for Google Earth resolution or higher, that's not going to be available. I mean, sub-meter data is not available over large areas for free, as far as I know. But don't be fooled by Google Earth. Google Earth is really, really interesting because it collects a lot of high-resolution data sources, but the spatial accuracy, the positioning accuracy of these images is not verified.
Then we got a question from Stephanie, if we could have, if they could receive the key URL for this presentation, including links to models prepared according to the phenomenon we want to observe. Is this something you can share?
Yes, we're going to share the presentation. And one thing I wanted to show you here is I have embedded these links in the presentation. So for example, this one is a Sentinel share link. If you just take it and copy it and put it in a browser, then it's going to take you directly to the time and location and the image that is shown on this slide. So I tried to make the presentation in a way that using these Sentinel share links, you can actually exactly follow up the places and the events that I wanted to show.
Steve is asking, actually, he's explaining that in Canada, they found a broken pipe from Domtar. It was leaking into the river. So he's wondering if we can see acid or other liquids and time-lapse data of damage to the environment.
In some cases, yes, because liquids are, I mean, any kind of pollution is going to influence the growth of vegetation. So you might not see it instantly, but you can recognize that something is wrong with vegetation health. But in other cases where it's leaking directly into the river and it contains nutrients, it's going to influence algae growth. But it's not a one-to-one relationship. If something is completely toxic, then it's not going to create a green signal of new algae growth in a river. But then again, it still might be possible to identify it based on the thermal signature. So Landsat images, they also have a thermal band. They allow you to follow surface temperature. And if the fluid coming into river is at a sufficient quantity and it's warmer or colder than the river, then you will see a signature. There, the spatial resolution is somewhere around 100 meters, if I'm right.
Andrew was asking if you mentioned the SkySat archive of a ½ meter resolution, if it's accessible at reduced price for NGOs, if there is other commercial data available for NGOs as well.
Well, I can show you the Gateway to the Planet nonprofit program. And here, I mean, the easiest thing is to contact us directly using the contact form on this website. Yes, both bundles, both the small and the medium bundle, include both PlanetScope and SkySat archive data. So it's possible to access both of them using this. I think it's a relatively simple procedure.
I would invite everybody for further questions. Just feel free to use our Sentinel Hub forum. Thanks again for all to be with us today, and a big thank you to you, András, and I hope to see you the next time.
Thank you for joining.